Hello class, this is Mr. Parsons here. I just want to take a few minutes and talk to you about scatter plots and predictions. One of the things that we use to help us with scatter plots and predictions is what we call a trend line. A trend line is another way of saying the line of best fit. And basically we find the equation for the line of best fit to help us make predictions among our scatter plot data. And so we look here, it's a tomato farmer. It monitors the number of bees that visits the garden during the spring and the number of tomatoes. So we're looking at the relationship between the number of bees versus the number of tomatoes. A through D is basically looking at if we did this manually. All right. If you did this manually, of course, you apply each order pair on a graph. All right, and then you'll draw a line of best fit based off the data, and then you'll make an equation. So that's what A through D is talking about. How could we make predictions? Once you make your equation, so this is your line of best fit. Once you make your equations on the line of best fit, which is in slope-intercept form, you can substitute either for X or Y to help make your predictions. But we have technology now, and so we can be a little bit more accurate using stuff such as our graphing calculators or Desmos, all right, to help us with making these trend lines and these trend line equations. And so we did a graphing calculator. We'll have an equation of y equals, so look, look at what happens. So this is Desmos, right? You know, I inputted this table in the Desmos, add my regression, look at my equation versus the equation that's given. And so a more accurate equation will be y equals 1.37x plus 5.7. And we can use this equation of our line of best fit to help us to make predictions. So you just type in then, your table, add your regression, and then look at that equation. That equation is going to be the equation of the line of best fit. Let's take a look at this example. Stewart estimated that y equals 5x plus 200 is an equation for the scatter plot. First of all, what you want to do is look at your scatter plot, identify the correlation that's going on. The correlation that we got here, look, as the curbside orders increase, the customers in store decrease. That represents a negative correlation. If we have a negative correlation, that means we need to have a negative slope. If we have a positive correlation, we need to have a positive slope. So if we look at this equation that Stewart estimated, look at the slope. It's positive, but the correlation is negative. So this would not be a reasonable equation because it's not a negative slope. How many in-store customers will we predict if there's 18 curbside placed? So we can look at the graph and help us make this prediction. What you want to do is look at 18 along your curbside and go all the way up until you like within the middle of your data. I'm in the middle of my data right here. All right. And then you want to look at the corresponding Y. The corresponding Y will be right here at 125. So we can predict that approximately 125 customers will be in the store if there's 18 curbside orders placed. All right, let's take a look at here. Herpetologists, which is people who study reptiles, look at the effects that temperature has on snake activity. This represents the temperature and how it affects the hours of activity for our snakes. So we use our graphing calculator or our Desmos, we can find the equation of our line of best fit. So in Desmos, of course, we add our table, type in the temperature for X, type in the hours of activity for Y, and we add our regression. All right, when we do that, look at our equation. And then we just round it. So we put this could be rounded to 0.25, this could be rounded to 5.8. So our equation could be y equals 0.25x minus 5.8. That represents the line of best fit on our scatter plot. Now that we have our equation, we can make some predictions. X represents the temperature, Y represents the hours of activity. And so it says if the temperature is 40 degrees, how many hours of the day would the snake be active? So you want to substitute 40 for X. So we're going to do 0.25 times 40, which is 10, and then 10 minus 5.8, which gives you 4.2. So we can estimate that the snake is active for 4.2 hours. If the snake has been active for 9.5 hours, what's the predicted temperature? So since we're given the hours now, we could substitute y for 9.5 in this equation. So 9.5 equals 0.25x minus 5.8. Now we want to solve for x. Add 5.8 on both sides. You're going to get 15.3. And then divide both sides by 0.25. You're going to get 61.2. So we can predict that if a snake has been active for 9.5 hours, the temperature is around about 61.2 degrees. Look at D. We want to find the equation. We want to use our equation to find the hours of activity when the temperature is 45 degrees. And how does it compare to the value given in the table? So our temperature represents our x. We use this equation, so we're going to do 0.25 times 45 minus 5.8. 0.25 times 45, that's going to give you 11.25. Subtract that from 5.8, that gives you 5.45. We can round it up to 5.5. And 5.5 will be hours of activity for the snake when we use our equation for the line of best fit. How does it compare to the table? Well, look at the table. At 45 temperature, right, the snake activity is 4 hours. So we compare the predicted versus the actual. We want to do 5.5 minus 4. That's going to give you 1.5. So there's a difference of 1.5 hours between the values of the table and within the equation. All right, what we want to do here, we want to look at this graph. And it shows the results of a survey of a person's age and the number of online purchases made in a week. And so we want to kind of model this data. What prediction for the number of purchases a 30-year-old will make? So your X represents your age, your Y represents your online purchases. Let's look at a 30-year-old. All right, we want to look at right here. And then we want to go all the way up until we're in the middle of our data with our scatter plots, which should be right here. And then look at the corresponding Y. All right, so we can predict that's going to be about, for a 30-year-old, they will make about 12 purchases in a week. Look at part B. If a person made 3 online purchases a week, how old would this person would be? So let's go to the Y-axis. Let's go to 3. Well, 3 is between 2 and 4. And then you want to go all the way, try to be in the middle of this data, probably right about right here. All right, and then we see the corresponding age. The corresponding age is before 60. So anywhere between 55 and 60 would be a good estimate. It's closer to 60, so we can say 59 years old. All right, and then for C, which function will best model the data for 20 to 55? So what we want to do, in Desmos, we want to go ahead and put in our table. However, look at the age, 20 to 55. So that's going to exclude the 64 until you want to take that out and then do everything else. So we did that in our Desmos. This is what our table will look like, and this is our equation. All right, look at the equation, we round it. This will be negative 0.33 plus 21.5. That looks like it's going to match answer choice B. Now let's take a look at this last one here. Children's Museum reports the number of visitors in a month compared to the number of rainy days in that month. The relationship can be modeled by this function. If there are 5 rainy days in a month, how many visitors should we expect in the museum that month? So what we want to do, let's go ahead and plug this in our graphic calculator or Desmos, right, in our table. All right, X represents the number of rainy days, Y represents the visitors. And so we did that. Notice, look at our equation. So we got 28.3 or 28.31 X plus 55.16. All right, now we want to go ahead and substitute, because X represents the number of rainy days. Substitute X for 5. 28.31 times 5 gives you 141.55. And add that to 55.16, we get 196.71. All right, so if we round it up to the nearest whole number, that's going to be 197, so we can predict 197 visitors. Find the correlation coefficient to describe the association. So we still did the same thing we did here. We type in our table where X is the rainy days and Y is the visitors. and we add our regression. Now we're looking for the lowercase r. The lowercase r represents your correlation coefficient, which is right here. All right, and if we round it to the nearest 100, that's going to give us 0.82. So 0.82 is the correlation coefficient. Now, since it's 0.82, we can say that it's a strong positive correlation. All right, so what we did here is we just went ahead and extended our understanding for scatter plots and correlation, and we went ahead and made a line of best fit or trend line, and we wrote an equation of that line of best fit to help us with making predictions on our graph. So I hope this helps with our understanding with scatter plots and predictions.